Okay, so 7e to the 2x minus 5 equals 58. We want to get that base in the exponent part by itself. So how are we going to get this e to the 2x by itself? What do we need to do? Let's add the 5. So 7e to the 2x power equals 63. And then what are we going to do?
Would we do the natural log?
So e to the 2x power equals 9. All right, so now we're going to change this into logarithmic form. Okay. So we're going to do our loop and swoop. This is going to move to the other side. And we have 2x equals log base e of 9. So the base of your power becomes the base of your logarithm. But log base e, that's the same thing as what? ln. So 2x equals the natural log of 9. And then how do you get x by itself?
Divide by 2.
Divide by 2. So x equals the natural log of 9 divided by 2. When you're plugging that in your calculator, make sure that so it opens up the parentheses when you type in that natural log. Make sure you close them before you do the division. Because if you don't close them, you're going to be doing a natural log of 4.5. That's going to do the 9 divided by 2 first. All right. So if you plug that in, and one thing to be careful about when you're doing your homework, make sure you're looking to see what it wants you to round to. Normally you round to 4 decimal places. So if we do that, you should get 1.0986. Okay. Questions with that? Okay. All right, F. Now this one's a little different. So 3 to the 2x minus 1 equals 7 to the x plus 1. Since our bases are not the same, you have to take the logarithm on both sides. So this kind of depends. You can either do the natural log or the common log. It's going to really depend on how it asks for it in the question, but they're interchangeable. Okay, so let's do natural log. So what we're going to do is we're going to take the natural log of both sides. And then we're going to use the properties that we talked about yesterday. Okay, if it's a power, where does it go? To the front. So we're going to take this 2x minus 1, move it to the front, this x plus 1, and move it to the front. When you do that, make sure you put that exponent in parentheses. So we have the quantity of 2x minus 1 times the natural log of 3 equals the quantity of x plus 1 times the natural log of 7. And now we're doing algebra. Okay. So the thing you have to be careful about, natural log of 3, that's just a number. Okay. So we're going to distribute 2x natural log of 3 minus the natural log of 3 equals x natural log of 7 plus 1 natural log of 7, or just natural log of 7. All right, now we want to get the terms that have an x put together, and the ones that don't have an x put to the other side. So I'm going to, maybe it's in a different color. We're going to add this natural log of 3 to the right. That's fun. Okay. And then we're going to move our x terms to the left. So we have 2x natural log of 3 minus x natural log of 7 equals the natural log of 7 plus the natural log of 3. We're almost done. We only want one x, so we're going to take a GCF of x, factor that out. And then to get x by itself, we're going to divide. Okay. So if we do that, we're left with x equals the natural log of 7 plus the natural log of 3 divided by 2 natural log of 3 minus the natural log of 7. Questions with that? Okay, when you're plugging this in your calculator, you are going to want to put parentheses around the numerator and the denominator. And then make sure if it opens those parentheses after the natural log, you're closing them after the 7. It's going to open it before the or after the natural log, close it again after the 3. On the bottom, it's going to open it in front of the natural log, close it after the 3, open it after the natural log, close it after the 7. So your parentheses are going to be a little excessive, okay? If you have one of the newer calculators, I've shown a lot of you how to do this. If you hit alpha y equals, and then enter, it goes ahead and it gives you the fraction, okay? And actually, let me see, I'm gonna check something real quick. Okay, so yeah, if you hit alpha y equals and enter, it'll bring up that fraction for you. Okay, so then you can just type in natural log of, someone help me out, 7, close your parentheses, plus the natural log of 3, and then move to your denominator. 2 times the natural log of 3, and then minus the natural log of 7. You should get 12.11.
Did you not have to put it in the parentheses?
If you create that fraction, if you have this newer calculator, then no, you don't have to put in the parentheses. If you don't have a newer calculator, you would type it in like parenthesis natural log of 7, close, plus the natural log of 3, close, close, divided by open 2 natural log 3 minus natural log 7. Yep. Okay. And if you're having problems getting that in your calculator, make sure I help you before the end of class. Okay. All right. Whoa. So we got x equals approximately 12.1149. 44.
4.
All right. Next part, I cut this last quarter and I didn't add it into the homework, so we're going to cut it again. You're welcome.
Thank you.
All right. Last thing, application. So an application of our compound interest formulas is instead of finding the value of A or finding the value of P, we find the time it takes. Okay. So the formula A equals P times the quantity 1 plus R over N to the NT power is what we're going to be using. So if we look at this, how long to the nearest tenth of a year? So right there, that tells us that we're trying to find what T equals. will it take $1,000 to grow to 3,600 at 8% annual interest, compounded quarterly? So we need to know A, P, R, N, and T is what we're searching for. Okay, remember, P is what you start with. So how much are we starting with? 1,000. And how much are we wanting to end with? 3,600. The rate, 8%, changes to be what as a decimal? 0.08. And your N, how many times is it compounded in a year?
4.
4, since it's quarterly. Okay, so we're going to plug in everything we know. So we know 3,600 equals 1,000 times the quantity 1 plus 0.08 divided by 4 to the 4t power. Okay, we're going to break this into pieces. Okay, so the first thing we're going to do is we're going to simplify this inside. Okay, when you do this, you need to be careful not to do any rounding. So you might have to write something very large. So if we take 1 plus 0.08 divided by 4, usually we get something nice. On this one we did 1.02 to the 4t power. Okay. Next, we want to get anything that's with that exponent part away. So we're going to start off with getting rid of this 1,000. If you need to, put a multiplication sign here. Opposite of multiplying is divide. To the other side. And 3,600 divided by 1,000 is 3.6, which equals 1.02 to the 4t power. Are the bases the same? No. So what do we need to do? Log both sides. So you can either use log or natural log. Let's just stick with natural log. So ln of 3.6 equals ln of 1.02 to the 4t power. By doing that, what does that allow us to do on the right-hand side? Move the 4t to the front. So the natural log of 3.6 equals 4t to the natural log of 1.02. We're solving for t. Everything's being multiplied by t. So we're going to divide by everything other than the t to the other side. So t equals the natural log of 3.6 divided by 4 times the natural log of 1.02. And then plug it in your calculator. And anybody want to take a shot at the number of years to the nearest tenth? So 1 decimal place. 16.2. Does anybody agree? Yep, I agree. 16.2 years. Okay, questions with that? All right, I'm gonna stop recording, maybe.